Okay, so that was one instance of OSPF that I showed you guys. Now I'm going to show you the second instance, and it's a bit different because OSPF can be run in both a point-to-point LAN, or a point-to-point LAN, or a multi-access LAN. So what you have to do is just get these routers on here, and y'all know I always have to do this. Alright, so there's our multi-access LAN. But instead of putting actual physical LANs behind these routers, i.e. putting another switch and connecting another crossover cable on all the routers, I'm not going to do that. What I'm going to do is just use loopbacks for this one. And this one. And LO1. So here's your two loopbacks, and I want this guy to be the ISP. Therefore, he will have a cloud connection to him. So, what do I do in this type of network? How is routing in OSPF any different? That's what we're going to talk about. But first, what do we always have to do? Basic configuration. Hostname, we'll do an enable secret of Cisco. Banner, MOTD. And go into the line. Go into the other line. Password Cisco, login, logging sync. I think that will do it. Lines. Oop. I didn't get into all the telnet lines. There we go. Banner, lines, secret, hostname. Got all those. Come in here. Oh, that's right. Do y'all remember the other command we did? It was service password encryption. Just so that all the passwords are encrypted now. We're going to open up Notepad, paste in our configs. Once we do that, we highlight everything. We change this to router 2. Open up router 2. And paste everything in there. So router 2 and router 1 are both configured. There's router 1, and here's router 2. We're not going to do the same commands for ISP because he's the internet router. Alright. So there's the basic commands to set up this lab. Now we need an addressing scheme, and we're just going to make it simple. We're going to do 192.168, 1.0/24. And we're going to say that this one has 100. This one has 60, let's see, this one has 30, and this one has 20. Actually, you know what, let's just make this 12. Alright, so there's all our loopbacks and what they need as far as addressing goes. So we'll have to subnet this so we know that router 1 loopback 0 is going to have 100 hosts. That's a /25. Router 1's loopback 1 will have 60 hosts. Therefore, he is a /26. Router 2's loopback 0 will have 30 hosts, so he is a /27. Router 2's loopback 1 will have 12 hosts, so he's a /28. So there's my CIDRs for everything. Networks will start here, 192.168.1.0 to 192.168.1.127. And of course that's a /25. This one here, 192.168.1.128 to, yes, even the teacher has to pull the calculator up every now and then. 128 plus 64 to 168.1.191 6. There's that one. Our next one will start at 192.168.1.192 and it will go to 224. /27, and this one will be the last one, 192.168.1.1, I'm sorry, 224, 192.168.1.240 /28. So there's your subnetting and your basic configs done on these routers. This ISP up here, he has a public address, so he's going to be 188.64.72.80. I'll just make it easy, 0. So that's the ISP's address. Alright, so that's the outside networks as if these had two other LANs coming off of them. What's the internal addressing that we're going to use? We'll just make it easy. 10.10.10.1 10.10.10.1 10.10.10.3. I misspoke there. This is 2. And we'll just give them a /29 to keep it easy. Alright, so hopefully you can understand the way this topology is laid out. This would be the internal network, these would be the other two LANs that you have coming off, and this is your ISP right here. And we're going to talk about configuring OSPF for this type of network. Alright, so now we're going to have to go into our interfaces and do our interface configurations. So first, let's just go into router 1, and I don't know if you noticed this green light here. I've already configured the ISP router, because again, he's not the same as router 1 and router 2. Why? Because he's the internet service provider. So I did the, I did the consoles, I did everything here, I did the fast Ethernet, and I did the loopback address, which is just going to simulate this cloud right here. I just simulate it with a loopback. So the ISP router is done. I'm going to go into router 1. And we'll just go into the interfaces. Interface fast Ethernet 00, IP add 10.1.1.2, 248, and a no shut. Go into interface, loop back 0, give him an IP address of 192.168.1.01, 255.255.255.128, and we'll go into interface, loop back 1, give him an IP address of 192.168.1.129. And we're done there. And again, loopbacks show up in the show IP interface brief, and they show up and up. You don't even have to do a no shut on them, because once you go into a loopback, it just automatically no shuts. So there's router 1's interfaces configured. Now for router 3, or I'm sorry, router 2. Fast Ethernet was 10.1.1.3, 255, 255, 255, 248. It would help if I put IP add and a no shut. Interface loop back 0. IP add 192.168.1.193. 224. Exit and interface loop back 1. B add 192.168.1.225. And show IP interface brief. You can see that these guys are up and up, and our routers should be able to ping each other. There it is. So now we should ping across the board. Router 1, ping, router ISP router, and you can see that those are both successful. So everybody can ping. Okay, so we see in our topology now that we have everything configured, everything's up and up, and again, oops, everything can ping. So why is this a problem for OSPF? Well, let's imagine that this little PDU is an LSA. Router 1's got 2 networks, 3 networks he's connected to. Router 2's got 3 networks he's connected to. Router 1's going to flood these LSAs out to everybody. Router 2 is going to flood these LSAs out to everybody. Now this topology is pretty small and controlled, but imagine if I had that many more routers hooked up. That's a lot of LSAs being flooded. How do we control traffic? It can be a little overbearing for the switch. So what we have to do is select a designated router and a backup designated router, which we call the DR BDR. So in this network, there will be a designated router and a backup designated router. Remember remember this process, because we're going to talk about it a lot, and this is the process that you have to configure in your skills packet. So we'll go into router 1. First thing is first, we have to configure OSPF. So I'll do network 192.168.1.0. I'll do the second network. So there's all my networks for router 1 and all my networks for router 2. Second network 192.168.1.224. And network 10.1.1.0.0.0.7. So there's router 2, all done. And finally the ISP, he needs to route as well. Router OSPF 10, network 10.1.1.0, oops, 0.0.0.0.7. End. See, they're taking a while. OSPF process number 10, adjacency, so they're just now, there's no routing table in router 2 or in router 1 yet. Why? Because they took a little while to establish neighbor adjacency. So let's do a show IP OSPF neighbors, and we can see that we have a DR and a DR other. Router 2, we can do a show IP OSPF neighbors. We have the BDR and the DR. ISP, we have show IP OSPF neighbors. He's got a connection to the BDR and the DR. Well, how did they find out what they were doing? And now if you look, show IP route, now everybody's got OSPF networks. Well, why did it take them so long to establish these adjacencies? Why, when I entered show IP route up here, right after I configured OSPF on everybody, why didn't I get networks up right away? It's because they had to elect a designated router and a backup designated router. Well, who's to say who the DR and the BDR are? Remember that there are 3 rules to finding a router ID. Router ID rules. Rule number 1 was, let's see, router with the highest router ID, meaning you went in and you did the router ID command from iOS. Rule 2, highest loopback address, and if that wasn't the case, then you would just do your highest active IP, highest IP on an active interface. These 3 rules determine your router ID. The highest router ID wins an OSPF election. So in this scenario, who had the highest router ID? Would have been router 2. He had the highest router ID. He should have been 192.168.1.225. The second highest router ID would have been 192.168.1.121. Let's verify that with these show IP protocols. OSPF 10, router ID 192.168.1.129. Router 2. OSPF 192.168.1.225. So those were the highest loopback interfaces, because remember, this address is only a loopback interface, but we're going to use it to ping stuff as well. Okay, so the highest router ID wins an OSPF election. Well, what if I want ISP to be the designated router? Because these are my LANs, I don't want them bogged down. ISP doesn't have that much to do. What can I do? I can configure OSPF priority, in which case the highest priority wins. Alright, so first things first, let's do a write on all these routers. So I've saved all my information. In the next video I'll show you how to manipulate the OSPF priority.